We live in an era where the boundary between the biological and the synthetic has dissolved. In Pokémon, the bioengineering of capture, we investigate the invisible infrastructure that sustains the coexistence between species and the technology that turned the impossible into routine. Today, we deconstruct the device that redefines the nature of matter. We begin our analysis at the core of the Sylph revolution, the Poké Ball, compressed matter. The first hurdle in understanding the Poké Ball is accepting that it violates our very perception of volume. This material doesn't simply open and close, it undergoes a structural phase transition. The synthetic apricorn polymer was engineered to toggle between two stable density states. Upon activation, the shell's atomic lattice reconfigures, physically expanding to create the necessary compression chamber. Once the Pokémon is contained, it retracts to the size of a golf ball for ease of transport. Observe the impact marks and the wear on the chassis. Every scratch is a reminder of the brutal kinetic force that attempted to rupture this atomic barrier while the polymer fought to maintain its integrity under extreme thermodynamic pressure. The capture laser is a projector of modified Higgs bosons. It doesn't shrink the animal, it collapses the distance between subatomic particles, transforming living biomass into biological plasma. Once inside, the quantum chrome lining reflects the specimen's energy infinitely. To prevent the psychological trauma of compression, the hardware initiates neural stasis, a deep sleep where time ceases to exist. In luxury models, the system processes endorphin simulations, keeping the nervous system in a state of low entropy and artificial comfort. But how do we carry hundreds of specimens? This is where the global storage system comes in. The Poké Ball is not merely a cage, it is a quantum data terminal. Through quantum entanglement, the Pokémon's vital signature is mapped and converted into high-fidelity digital information. The teleportation we witness at Pokémon centers is, in fact, the transmission of this data matrix over high-frequency fiber optic networks. The matter remains in a plasma state within the grid, awaiting a rematerialization request at any terminal on the planet. It is the logistics of life, treated as bits of information. The difference between success and failure lies in the sampling rate. A standard Poké Ball possesses mid-latency sensors. If the plasma oscillates, the field collapses and the matter is violently expelled. The Master Ball, however, operates at an atomic-level radio frequency. It generates an unbreakable force field that nullifies quantum uncertainty. There is no struggle. There is no failure. It is the pinnacle of human control, the capture of a biological deity through the sheer brute force of particle physics. We look at this sphere and see a tool, but science sees a technical marvel that borders on the impossible. The Poké Ball is a constant reminder that, with enough engineering, even the laws of physics can be bent to fit in the palm of our hand. The Poké Ball is the first stage, the capture of matter. But once life is translated into stable plasma, it becomes something more. It becomes information. Where does this data travel when we send it away? In the next episode of Pokémon, the bioengineering of capture, we investigate the PC system. The digital ether. We will unravel Bill's invisible network and the miracle of consciousness digitization, where the ether meets the silicon. Fictional GeograFIC, exploring the mechanics of the extraordinary.